Welcome, everybody. Tonight, we're going to be working on our Unit 8 exercises, which covers these two types of data structures in Python, one being a set and the other one being dictionaries. The exercises that we're working through tonight are the ones that you see listed here. And I should try to get my descriptions on screen here too. So I might either pull up the book. I'm trying to see if I have it maybe preloaded in my tabs here already. I think I have to pull up the book. So let me just go ahead and do that really quick. So I do that through Vital Source. Not that I'm trying to plug them, but that's just who I'm using. And we are in chapter 8 in the programming exercises. So let's read the first set of exercises here. And exercise 1 says, write a new version of the program called int name pi from chapter 5 that uses a dictionary instead of if statements. Okay, so all right, that kind of creates a couple of issues for us here. And that is that we need to have basically that exercise from a previous iteration to look at. And what I'm going to do is I'm dropping the program into the chat. I don't normally do this, but that way you have a starting point. So all you have to do is take that code and tweak it, because that's what I'm going to do, right? And so on my other screen here, and I'm doing a couple of file maneuvers here first before I move it over. I have preemptively created a Unit 8 folder, and here it comes on screen, and I drop that program in there. So what I'm going to do right now is I'm just going to go ahead and I'm going to open this up in Spider like so. I'm going to make sure I close all my previous tabs here though. And then I just want to kind of review this. I don't know if you guys remember this program or not. It seems like a lifetime ago, but this is when we were learning about if statements. And we were also learning about functions and main methods and stuff. But basically the way that this program goes is like this. We ask somebody to enter a number under 1,000, right? We convert it to an integer, and then we process it and try to figure out like what its name is, right? And I don't know if you guys recall this one at all, right? But this is quite a while ago. So in other words, if I type in a number, it'll tell me exactly what the name is. And it's all done with if statements. So I'm just going to demonstrate it here really quick. And so if I, type in a number like that, it's going to say 789. It's going to take the number and convert it to words. And the way that we did that is we used if statements and math to determine where stuff sat, right? And that was kind of a weird way to do it, but it did work, right? All right, so we're going to borrow from this. So we're going to leave this up on screen. So hopefully you guys grabbed it out of the chat, opened it up, and you have it sitting there. And we're going to borrow stuff from this to build our new program. So I'm now going to come up to the toolbar, create a new file, do a save as, right? I'm dropping it in my Unit 8 folder. Yeah, you can see I got a bunch of other stuff in there we're going to use for tonight too. And I'm going to call it exercise 8_1. All right, zooming in. And what this program ultimately is going to do is this. That's what it does. The same as the previous one did. So I'm using the same comments. Now, with the previous program, we used functions that had complicated if, else, if logic in them, right? And we're going to convert this to an approach where we're going to use dictionaries to develop a pool of the number names that we're just going to pull from as we need dynamically. So what I'm going to do is I'm going to code these with a little copy paste, by the way. And then to speed things up, because we have a lot of material to go through tonight, I'm going to paste it into the chat. You guys will be very thankful. But here's the first thing, and I'm just brute force creating a dictionary, right? And I'm starting with one called digit names. So in other words, the ones position in the number column, right? And so if we're just looking at that position in a number, what are all the different names that we can give the numbers? Okay, so like if they're in that position, it's 0 through 9, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, right? And this is a dictionary, so I want you to notice it's key value pairs. The numbers themselves are the key. There's a lookup, then there's a colon, and the value for it is the text that describes the number. Okay, now think of the example from the Kahoot where we were looking up a string, harpo, and then pulling back a number. Now we're doing the opposite. Now we're looking up a number and pulling back a string. A couple of other little interesting tidbits here. Do you guys notice this character here? Right. So I have really a dictionary that if I typed it all on one line would probably end up over here somewhere way on the right. It wouldn't fit, especially at this zoom level. So this is actually a continuation character. This allows me to take this data structure and continue it on the next line. Now, true, if I have word wrap turned on, that would happen automatically, but this allows me to actually put it on a separate line of text. So just another teaching moment. So this is for the digits. This handles all the things in the ones column, if you will, right? Then I have another dictionary that's going to hold the second position. And okay, well, this is the ones, this is the hundreds. What do we call the one in between? Well, normally I would call it the teens, but there's 11 and 12, which aren't teens, but we'll call them teens anyway. So I'm going to have another dictionary called the teen name. So there's that one. Oh yeah, and I forgot I was going to be kind and paste this into the chat. You guys are typing, right? All right. And then I had somebody request that I send the file again. Oh wait, let me hit send first. Here's the send. So you guys have the code in the chat, and here's the file again. There you go. All right. So now you have both of those dictionaries. Okay, so now you're figuring out what's next, right? So if this is the teens name, so in other words, what happens when I have 11, 12, 13, 14, 15? These are all specified. But notice it really covers 2 digits, right? Then we also have like what happens really in this column once we get above the tens, right? Or the teens, if you will. Then we have what we call the tens name. So I'm just going to paste that in. So if we have 90, 80, 70, 60, and notice order doesn't matter here as long as the values are correct. We have number lookups with word results in the chat. It's pretty handy when your teacher does that, though, right?
100%.
Really speeds up the coding, right? Sometimes it's builds character to type. Sometimes we don't want to waste the time. All right. I'm still going to use a main method to drive my program. So this is kind of interesting because this data is global. It's going to sit outside of all the functions and methods. So that's global data. I am going to define a main function, right? And then, I'll do stuff here. But then I also like to make sure I call it. You remember that part of it? Make sure you call it. All right. What are we going to do in the main function? Well, the first thing we're going to do is we are going to prompt our user. This comes straight from the other program. So you can copy and paste it yourself, right? But there it is. So I'm setting up a variable called value that's going to receive input, convert it to an integer for processing. Then the next statement, this is where it gets interesting. I just go right to a print statement, and I'm calling a function, which I don't have yet, called int name. right? Compared to the previous program where I had one called int name, one called digit name, one called teen name, tens name. You guys got all that? We're going to replace all those functions now with one function. This is kind of the power of the dictionary coming into play here. So I need to create that function. So let's come down here and I'm going to define a function called int name. And we're going to throw a number into it. We're going to pass some sort of a value into it. Okay. If you're geeky and you want to keep track of your functions, what does this function do? It turns a number into its English name, any integer under 1,000, and then it shows you what the return is. So it tells you what the parameters are going in and what the return value is coming out. All right, we'll start the function with these two lines. Right. So we're going to take the incoming number and store it in a thing called part. Right. And so that still needs to be converted, basically. It's the unconverted number, but we're storing that just in case, basically. Then we're going to set up a string variable called name, and that's where we're going to store all the words, like these words as we're building this string. Right. So if you're building a string like this, where do you start? Well, you start with the hundreds, right? So how can we do that? Now, I am pretty aware of the fact that I created these dictionaries up here to cover the digit names, the teen name, and the tens name, because those are all kind of weird. But when it comes to the hundreds, I mean, it's 100, 200, 300, 400, 500, 600, 7, 8, 9. See what I mean? You just use the plain number name to say 100. So I really don't need to create a dictionary for it. All right. So watch what I do here. This is kind of interesting. Is we're going to write an if statement. So we're still using if statements. And we're going to say if, okay, the unmolested number, which is in part right now, is greater than or equal to 100. So in other words, if it's like, if I type in 45, I don't need to figure out what 100 it is, right? So I don't even need to process it. But if it is greater than 100, then the name string is going to take, and this is where it gets interesting, we're going to take the digit name from this dictionary, right? And to access its members, we still use square brackets, but we want to give it a number to pull back a string. So whatever I do here, like for example, if I type the number 0 in here, it's going to return a string. And then all I have to do to get it to say 100 is attach to that space 100 as a string, and that'll get stored. So this will come back with a string and it'll get stored here. So 0, 100, that doesn't make sense, but I think you kind of have the point there, right? So, but I do need to do math, because if somebody types in, for example, 789, how do I just get the 7? Okay, if you're wondering, just divide by 100, right? But I also don't want a remainder, so I'm going to do integer division on it. So 2 slashes. So instead of 0 here, I'm going to say the part, which is the whole number, divided, right, with 2 slashes, divided by 100. That's integer division, no remainders. So 789 would resolve to 7. It would look up the 7 and return the word 7. See how clever that is? That's pretty rocking, right? Yeah. So maybe you're seeing the value of this now. Maybe not. Right. All right. Then, since we're done with the hundreds, now we're going to take the part, which is the number in progress of being evaluated, and then we're going to mod it by 100, because the modding will now give us the remainder. Okay, so in other words, if I divide this number by 100 and look at the remainder, what number do I get? Don't all rush to answer at once. The answer is 89, right? Because if I would mod by 100, the answer would be, or divide by 100, the answer is 7. Now I'm looking for the remainder. The remainder would be 89. That's what I'm left with. So we're done with the 7, and now we're going to process the 89, right? And it's storing it there, right? That's only if the number is greater than 100. Now, next if statement. Now we're going to check to see if what's left over, the partial number, I guess, if you want to look at it that way, is greater than or equal to 20. Why? Because when you get above 20, you can use the tens name. You know, so for example, 20, 30, 40, 50, 60, 70, 80, 90, right? And so that's what we're processing next. So name will equal, if I can type it, name plus, well, we need a space in there. Okay, so what is name currently at this point? Well, if it was 100 or 700 would be here. 700 space, that's what we're doing. And then we're doing some more math. Now we're trying to figure out the tens name. So we're going to use this library. So we're going to say tens name, square brackets. And once again, whatever number we put in here, it's going to pull that back the text that goes with it, but we're going to do it with math. So we're going to say, we're going to take that partial number and we're going to do integer division of 10 this time. Right? All right. So think about what happens there. If I have 89 and I divide it by 10, what integer divide, right? So no remainders. How many times does 10 go into 89? 8, right? 8 is the answer. Yes? Yeah, 10 goes into 89 8 times with 9 left over. We're only looking at the 8, right? But 8 isn't on my chart. Then I have to multiply that by 10 to turn it into the 80 to pull back the 80. So it'll find the 80 in the table and then pull back the string, and I'll have 700 space 80. Still got to work out the 9 though. So that means we're going to take the remaining portion, right? And we're going to mod it by 10, because if I mod 89 by 10, what's my remainder? 9. Now we have the 9 to evaluate. And this time, instead of going to another if statement, we are going to go to an else if. So we're going to do elif. And we're going to say if the part is greater than or equal to 10, then what do we do? No, we're not looking at the 10 or the teen or the tens name. We're looking at the teen name. So why a threshold of 20? Because the names for numbers change. Why the threshold of 10? Because the names for the numbers change. This is only in English, by the way. In most other languages, you know, the teens are very, you know, they're like, you know, I'm thinking of like Greek, you know, if I was to say 15, I'd say dekapede, right? It's like 10-5, you know, is like how you said in Greek. And it's consistent, right? We don't have 11 and 12, which are all messed up, yeah, or teens, yeah. So that's the why we do it. All right, so same approach here. We're going to say name equals, and it's going to be really, really similar. We're going to take the name that's already built up. We're going to add a space to it. Let's use double quotes, and then append to it the lookup on the teen name, once again with square brackets. And this time we're left with a single digit number at this point. So I don't have to do any math. I just throw that in there. It's going to look it up on the chart, right? And it's not, I'll correct that. It's not a single digit number, but it is less, greater than 10 and less than 20, right? And it'll just look it up And if I find a 16, it'll say 16. And then finally, part will be set to 0. And that's all the logic it takes to do this. And then we're going to return at the bottom name. All right, so I know that I'm kind of rushing ahead here, but that's all the code. Now I want to show you the value of this, right? So part of the value of this is the fact that we went from a program that had 82 lines of code and a ton of if statements, even though we like truncated them onto one line. You guys remember we did that too. And we still had if statements, right? And then we converted that to under 40 lines of code, but we do have the dictionaries, right? So the data that we're pulling from is here. We're just using some simple logic to pull the data out of the table. And let's just run it and prove that it works. I'll put in the same number, right? Missing one. Nobody caught me on it. 780. Oh, we have to do one more thing. So after we get past this if statement, we have to do one more if. If the part is greater than 0, then all we have to do is take the name of that single digit number. So still following the same pattern. The fact that nobody spoke up concerns me that nobody was getting it, but that's okay. It's the end of the semester. Everybody's burnt out, right? Whatever's left over from the previous equations, the single digit number will come here. And notice the digit name, right? Single digit number will just return the name. All right, so there it is. I'm going to run it again. 789. And, really, you can put it in a big loop if you want, but you can go ahead and run it again, test some like weird number. It should work with every number, every circumstance, as long as it's under 1,000. All right, folks, that was exercise 1. All right, really quick for screenshotters. Top part of the code. See how fast you can screenshot. 5, 4, 3, 2, 1. Scrolling. Now you have to watch a video for the rest, and there's the function at the bottom. All right, moving on to the next exercise.
Hey, Ty.
Yes.
Mine's not working.
Oh, well. I'm teasing. I'm going to pause for a second. Let's take a look. All right, on to the next exercise here. So next exercise is 8.2, and I'm just looking at the directions on this one here. Write a program that counts how often each word occurs in a text file. Okay, that's kind of an interesting one, and really super vague instructions on top of it all, right? Over to Spider, let's get the new program going. So new file, save as, and this is exercise 8_2. And okay, so a couple different things here is, first of all, the main directive of what we're doing is this, right? I'm going to just paste this in here and zooming in. So we're going to count how many times each word occurs in a file. So this means what? That we're reading in a file, right? And we're going to prompt our user to do that. So here's your prompt in the chat, by the way. So we're going to prompt the user to input the name of a text file. And then we're going to open that file. Notice with the R switch, read only. We're just going to read it in and then contend with it. We don't need to change the file. We're just counting how many times the words occur. We're also going to create a dictionary to hold the words that we're reading in. I'm going to call it counts, right? And what's going to go in there, I want you to think about the way I'm going to do this. I'm going to grab each word and throw it into the dictionary and then count how many times that word happens. And so that my key is now going to be a word and the counts are going to be the values. The key value pair is the word and how many times it happens. But I'm just creating an empty dictionary and notice the syntax. All right, devil's advocate. Don't you also use curly brackets for sets? Yeah. How do we know it's a dictionary? Once I put a key value pair in there, it becomes a dictionary. That's how. That's Python for you, right? All right. So now we need to do a little processing, but we also, frankly, need files to work with. All right, so here's the other goofy thing that I do. And when you guys saw before, I'm like, oh, you got a whole bunch of files in your folder already. And here's one that I like to do a lot. Here comes in the chat. So I just use Beatles songs because everybody kind of knows them and they're usually pretty safe lyrics, real frankly. And that's a pretty good tune because for a couple of reasons, right? It's got a lot of repeating words in it. See my strategy here, right? So how many times do they say yeah in this song is like kind of a thing, right? But yeah, I just went out to the internet. I Googled She Loves You lyrics, copied it from the screen and pasted it into a text document. And here it is. And I'm sharing it with you so you can save the time of typing. But you could do this with any text file, by the way. Doesn't matter what it is, right? That's the beauty of this. But I want you to notice real carefully how it's labeled. She loves you, all lowercase, no spaces, no uppercase, right? Dot text, right? So that's what we're going to get prompted. Okay, so that's what we're throwing in there, right? When we're prompted. And now we got to process that. So for every line in the in file, right? That's where we're saving it when it's coming in. Remember, when we read in a text file, it reads it in as a list of lines. That's a good way to say it, right? So INF is really a list. Each list item is one line of text. So when I open this up, this is in one list item, that's in one list item, and then we're going to traverse this, right? That's the next step. So for every line in the in file, we're going to convert it into words. Now we've done this before. I don't know if you guys remember, but we're going to take the line and we're going to run the split. I got to spell it right though. Split method, which looks for spaces, and every time it hits space, it splits it into a word. Okay. And then, so words also is a list, right? So what happened is we went from this being in a list to then each word in the line being in a separate list, right? That's the data structure we're dealing with. Now that we have the words in a list, now we can traverse the words. And so we can say for each word in words, and I also want you to notice the singular and plural usage here. Words is the list of words, and then each singular word is a word inside of it, right? All right. And then for each one of those words, for each word, better way to say it, we're going to take the word and we're going to run this command called rstrip, right? And this is a specialized command which allows us to basically strip extraneous characters from our words so we don't count the characters. So for example, I wanted to strip out periods and commas. I don't want to count those. I don't want those to be part of the words. I just want those out of there. And because Python allows this, I can chain methods and also switch it all to lowercase. So she with a capital S doesn't count separately than she with a lowercase s, right? So converting it all to lowercase and getting rid of the punctuation marks. All right. Then if the word is in the dictionary. That's what we're saying here. If word in counts, then we're just going to add to the count. We're just going to say counts word plus equals 1. That's assuming it's already in there. The first time, a word goes through, of course, it won't be. So the else will hit instead. And then we will take the counts word and set it to 1. So in other words, this is really weird. So this really simplistic command grabs the word, puts it in the key, and gives it a value of 1, or adds 1 to the value that's already there if it's already there. And that's all the processing, folks. This is crazy, powerful, very minimal amount of code. Make sure you close your file. So what do we say? inf.close, right? And then we just want to output everything. Right. And so I say, okay, so I'm going to do this like primitive thing first. So I'm just going to show you if I want, and I'm going to do just a print command here just for a blank line, but I could just say print counts. And I want to show you what this does first. Okay, so I'm going to run this. I'll feed in she loves you.txt, and there it is. Okay, so it already processed it. Notice how fast it was, right? But what the dictionary looks like, the words are the key and the count is the value. Some stuff happened a bunch of times. Some stuff only happened once, but everything was counted. And I can just print out the whole dictionary and it looks like a dictionary. Curly brackets, key value pairs, separated by commas. Okay, that's kind of primitive though, right? That's not very nice looking. So if we want it to look nicer, we can say for word in counts, and then this was my print statement. And just so you guys don't have to type it, this is my print statement. Doing a little bit of formatting to make it look a little nicer. What am I doing? I'm just laying it out side by side so it'll go top to bottom instead of a list that's really hard to read. So when I run this again, I can say she loves you.txt and it works. And this time it's looks a little bit more like a list. And I know I could format it to even look better, right? But pretty neat though, right? So it looks like you is the number one word in she loves you, by the way, followed by yeah, she, and loves, apparently, if you guys care. Right. When I have a little fun with it, I do have a few other Beatles songs here, so I'm just going to throw these in the chat too. You guys might have use for these later, just fair warning. There's Hey Jude and Blackbird, right? And so I can run this now on any text file. This is what's so cool about this. So if I want to put Blackbird in there, or if I want to put Hey Jude, want to check it out. They haven't got the na-na-na-nas. I didn't put anything about parentheses in the R strip, so those are included as words. But hey, I can adjust. And I see exclamations too, so I could filter for those. Right, so if you wanted to filter for those, you would just add those characters in here and it would remove them. Right? So I could get rid of the dashes. I don't know. The na-na-na-na-na-na-na is pretty cool. I know I'm being goofy, but okay. So that's exercise 8.2. Everybody okay?
You want us to screenshot 2 pictures of the actual when we run it because it doesn't fit in one picture.
Yeah, you know what, Juan, if you just give me the top part of it, like if you like if you ran it and just showed me that, not with, I'd be like, yeah, that's good.
Perfect.
Right. Because how do I know it worked? Well, I could see the numbers on She Loves You. You know, the top couple tell me that it's right or wrong. Right. And what's fun about this, you know, if you want to like feed something else into it, you got a different text file you want to throw in there, or you know, a different set of lyrics where there's a lot of repeat and you want to see how many times they repeat something, you can drop it in there. It'll work. Save it as a text file and it'll process any text file. You know, and you want to double check your work, ask AI, you know. And, oh, thank you, Hunter. Hunter put in an alternate song for us. That's a good one too, for sure. Safe lyrics, you know, that's the other important thing here is there's a lot of songs with not safe lyrics. All right. We're at 9:10. Let's take a really quick short little break. Let's try to make it like 3-4 minutes so we can code through the rest of the stuff. We got a lot of stuff left to do yet. So I'll see you guys in just a few. All right, we're going to move on to the next exercise, which let's see here is exercise 8.4. Oh, this is a great one. I say that about all of them, right? So implement the sieve of Aristophanes, right? So I love this stuff because it's all these like ancient Greek mathematicians coming back to haunt us. And given the fact that I'm also Greek, I find it even kind of like, I don't know, ironically humorous in a way. And basically, it's a function for computing prime numbers known to the ancient Greeks. So it says choose an integer n, and this function will compute all prime numbers up to that number. First, insert all the numbers from 1 to n into a set. Okay, sounds like a loop. Then erase all multiples of 2, except for 2, and that is 4, 6, 8, 10, 12, right? Then erase all multiples of 3, 6, 9, 12, 15, etc., and then go up to the square root of n. So in other words, if I put the number in as 25, I would go up to the 5, and because the square root of 25 is 5, 5 times 5 is 25, to erase all the multiples up. Okay, so I want to show you what this means because there's this really cool little graphic that they have on Wikipedia of all places, and I want you to watch. Okay, yeah, sorry. And all right, I want you to watch this little chart here. I'm going to refresh it. Watch the chart. First, the chart removes all the multiples of 2. Okay. And now I wish it was going faster. First, all the multiples of 2. A little faster, please. Then it will go through and grab the next available number, 3, right? It doesn't have to check 4 because all the 4 stuff is already out because that's a multiple of 2, right? Now it's checking everything that's divisible by 3 that's not already crossed off. This is a really primitive formula if you start to think about what they're doing here. But the fact that they even thought about the concept of a prime number, remember what a prime number is a number that's divisible only by itself and the number 1, right? So here they're up to 7. We're going up to 120. What's the square root of 120? How far up will it go to check? Yeah, nobody can answer that question. But notice now, any number that is not divisible is now being marked in that fuchsia color, and those are all the prime numbers up to 120. Right? So we can use this as a check for our program. But as you can imagine, there's kind of like this repetition that's happening here. So that should tell you in your brain, one of my problem solving tools is a loop, right? And we can take all these numbers. We were told to put them in a set, right? And then we would remove numbers based on their thing. And yeah, we can do that with sets. Okay, let's go back to Spider and start coding this. So let me see if I can find Spider here. There it is. New program, save as, right? This is exercise 8_4. What I think is fascinating about this little problem is how little code it takes to actually create it. It kind of blows my mind, actually, right? Like some of these really complicated things that people figured out like thousands of years ago. Why are prime numbers valuable? That's a separate question. Now, because we're going to be doing some math here, we are going to be using two math functions that we have to import. So the first thing you want to type is from math, our math libraries, import the square root command, because we're going to use square roots here because that tells us where to stop. And then we're going to use floor, which gives us like basically floor division, but in a more efficient way than the double slash way, because we can use it as a method then. And I'll show you what I mean in just a moment. First thing that we're going to do is we're going to prompt the user for a value. So there's that. And let's see if I can help you guys out with the chat here. So we're going to prompt for a positive integer, convert it to an integer, store it in a variable called n, right? And I'm using n because it really matches up well with the formulas. Now, I think the other thing that's kind of interesting about looking at some of this stuff online, right, is they actually talk about how this was developed, what it means, what it's used for, what the sequences are, and how they figured it out. But they also, check this out, they give you the algorithm as pseudocode. So in principle, you could convert this to any language. Notice the use of inputs, outputs, declaring stuff, like arrays or lists or whatever, for loops, if statements, for loops, et cetera, et cetera, et cetera. And look at the keyword here. What's that? Okay. Anyhow, doesn't correspond, by the way, but if your brain's telling me that it was corresponding, you would be incorrect. All right, so here's our next piece of code. I'm throwing it in the chat first. And with this one, we're starting with all the numbers from 2 to n. So we're going to prompt the user. And for example, in the Wikipedia example, they used 120 as their number. That's the number they're going up to. And if I used a calculator and I put 120 and then I do the little square root thing, does this even have a square root? Yeah, right here, right? It would count up to 10, basically, maybe 11, and then it would figure it's done. So it wouldn't divide anything past 11, is what that's telling you. So this is going to do this, though, and this is really kind of a bizarre little command here, because we're putting in a range command, which means it's going to count from 2 to n plus 1. Remember, the range command, you always have to go 1 past it. So if I want to go to 120, it's going to add 1, take it to 121. Then after it creates that range of numbers, so it's basically creating a list, it converts that into a set and stores it here. So primes becomes a set of all the numbers, kind of like the Wikipedia box with all the numbers not colored out, right? That's what's going on here. Then comes the loop inside of a loop, and I'm just going to drop it all on the screen here and just talk about what it's doing. This is the same algorithm that's on that Wikipedia page. It's just trimmed down to Python syntax. But once again, it's going to loop through. So in other words, it's going to count from basically the number 2 all the way up to the square root plus 1. And it's really not the square root plus 1. It's the square root. We take the floor of it, meaning we're omitting the decimals, and then we're adding 1 to it to go 1 beyond. So in this case, we'd round down to 10 and then add 1 and go to 11. And that's what I determined before by just kind of doing it with the calculator. And then for every time it does that, it discards the inner loop and outer loops counters. So like when this starts, this will start at the number 2, and then it'll go through, start at the number 2 here. It'll be 2 times 2, 2 times 4, etc. It just keeps looping through in sequence. This one stops when it gets halfway through because it doesn't need to go any further. This is why the algorithms are actually clever, because they realized they didn't mechanically have to do all the divisions. They figured out that they could shortcut it. That was the brilliant aspect of this. And the value of prime numbers allows you to do some really advanced calculations, which maybe explains how they were able to build such weird and incredible things thousands of years ago with no computers, or at least what we thought were no computers, right? We talked about that too. Finally, we're going to do a little output here, right? And all the output is going to show is what's left in the set. Now, set information is not sorted. It's thrown in there randomly. It has no index numbers. It has no key value pairs to organize it. So when we run the sorted command, it actually finds everything in there and puts it in order to display it on the screen. Right. So this is all the code to do that. I think it's amazing how little there is. So I'm going to start with a really small number. I'm going to put in 25. These are all the prime numbers less than or equal to 25. All right, I can verify that, right? I'll run it again and do 120. That was pretty fast, right? I'll run it again. You guys know where I'm going with this already, right? I'm going to start putting in some big numbers. All right, I'm going to go up to 7,894. All right, pretty fast. So these are all the prime numbers up to that number. Weird. Okay, thanks. I really needed to know that, I guess. But this is one of these crazy things because they have actually computer algorithms running on big supercomputers that are continuously looping, calculating additional prime numbers that have never been known before to man. I kid you not, there are computer programs that continuously run to calculate this stuff. And I'm just going to do kind of a little bit crazy large number here. I want you to notice how big that is. And let's watch how long that takes to process. The other ones were almost instant. You guys running a timer on this? All right, so most people would be like, it's not working. It's broken. It's not doing anything. I think I should give up now. I should kill my console and restart it, right? Because look, my console's got the red thing going on. But is it going to work, or you guys think it'll fail?
I think it'll work.
Should work.
Yeah, it's gonna work. That's what I think is really neat. Now, as a point of reference, 16 gigs of RAM running on an SSD, 10th gen i7, probably overclocking at around 4 gigahertz. I am running a ton of other stuff, including video streaming, recording, screen capturing, all that stuff all at the same time. But it is running through, I don't know how big that number is, thousands, 123.5 million iterations a bunch of times over. Like wherever the square root of that number is how many times it's going to run through those loops. And there's an inner loop and an outer loop. All right, so I'm still waiting. Still waiting.
I have a question while we're waiting.
Yes, George.
Isn't one a prime number?
It is, but they're omitting it because it breaks the sequence because you can divide it into everything.
Oh, okay.
Right. So that's like the universal divisor. Yeah. So that's why they omit it. Yeah. Good. Yeah. But good point, right? Like why do they skip one? And why do you skip 0? Well, you skip 0 because you can't divide by it. All right. This is still running, right? All right. While it's still running, I'm going to start pressing forward to the next exercise. I don't want to waste the time, basically. So let's go look at the next set of instructions, and then we'll kind of go from there. I will, well, actually, we'll leave that Wikipedia page open. All right. So now we're moving on to exercise 10. Write a program that reads in 2 text files and prints out in sorted order all the words that are common to both of them. Interesting. Okay, so now we got, so what do you think? We're using a set or a dictionary here?
A set.
Yeah, I think that's a wise choice, Laura. I think that's a pretty intuitive thing. And I think the key is because we're looking for things that are in common. Remember that intersection slide, right? Where they're over the dog, it was overlapping. All right, so that's kind of our directive here. So let's go ahead and start to code this. Let's go back to Spider and see if we have a solution. Not yet. It's still running though. And that's okay. I'm going to keep working like nothing is going wrong. Right. It feels like something's going wrong, but it's not. Exercise 810. And for this one, I'm going to drive this. Oh, you see what I just did? My bad. I want to make sure my other file's okay now because okay, I'm good. I just want to make sure now I can just blow all this away, right? So I did a save as opposed to a save. I am going to use a main method to drive this one. So if you guys want, go ahead and pre-create that. And I do the junk text on purpose to keep the indent there. All right, now I'm going to get rid of that. And we are going to start with reading in two files. So I don't know if you caught that part in the instructions. They want us to compare the contents of two files. So we want to read those in. Now, reading in a file. All right, so here's the process. We're going to do the same thing we kind of did in the previous one, where we open the file for reading. We read all the words into a set, and then we split all the words apart and put them in a list, and then we can check each word to see if it's already there, and then we'll return the words. Okay, so this is where it gets kind of weird. But the way that I'm going to run this is I'm going to create two data structures here to hold the results of this function I'm about to build called file words, which is going to read in the file, prompt, read in the file, process the file, and send it all back in a data structure that we can put here. Then once I have this data structure, I'll do it with the next file in a separate data structure, and then run some methods to compare them, and we're done. Right? That's how we're going to do it. So I need to build this function here. So let's come back to the margin and define it. So we'll say file words with parens. We'll start by reading in the file. Kind of pedestrian, so I'm dropping it in the chat to speed things up a little bit. Now, okay, if you're going in the back of your brain, hey, should we be putting this in a try thing? Yeah, you probably should, but I don't want to do that right now. I want to just get it to work, and then you can put it in a try, right? Then we're going to create a set to hold the words, and that's just inside the function, so temporarily. Then we're going to loop. And then I'm going to give you both the loops right away here. And you want to fix that indent. This indent should be here. So basically, once we've read the stuff into a set, right, we're then going to process it, but we're going to first process each line of the file, split it into parts, and then traverse each word in the parts, and then take the word and add it to the data structure. And then when we're all done reading through that, then we're just going to return words, which is the data structure that will get stored here. And we're going to do this, here's the fun part, twice with two different files. So this seemingly simple command here in the main method is really doing a lot of work. And yes, once again, you could put a try block in, you could put while loops and all that stuff. You want to get fancy, totally doable. All right. So that's how we read it in, process it, break it into pieces, and then put it into a set. Now, the other thing is we need to process that. So we're going to process it as follows. We're going to build a set that is going to take the intersection of the two. So this is a function, or excuse me, a method that exists for sets that takes a look at the one set and the other set and tries to determine where the intersection of those sets are. And that creates a new set based on just that stuff. So this is going to tell us the common words between the two files. Then we're going to output it. All right, so it's a little message. And then because there's multiple objects inside here, multiple words, we're going to traverse them. And notice once again, we're sorting the words on the way out. So there'll be an alphabetical order on the way out. And so what we're going to see here in the output is only the words in common. So I need 2 text files to test this. This is the whole program, folks. I think it's pretty amazing when you look at how little code it takes to really pull off some of it. Oh yeah, the other program is still running. I'm finding it a little funny because now I need to run this program and I can't.
Are you able to stop it?
Yeah, I'm probably going to. Has anybody's finished yet? Does anybody have like a next gen processor, like some Ryzen with like a screaming fast video card or something? Anybody?
I could have ran it, but I didn't. Mine was.
Yeah. I assure you this would complete, but it shows you though, like if you can imagine they are now calculating prime numbers up to, I don't like 1 trillion digits or something. And this is why the computer systems have to run continuously to calculate those numbers. Right. I am going to stop the console. And we can try it again with a little bit smaller number. Maybe it would take 1/10 the time. But we do need to run this one. So I'm going to execute this program. And remember I have those Beatles songs sitting out there. So I have blackbird.txt and Hey Jude. And actually, let's do She Loves You. And I could do like R strip, lower, all that stuff. Right. And here you go. Words that are common to both files. U, A, B of only the to your. Yay. Or let's try it again. And you can do Hey Jude. Oh, you got to spell it right. See, that's why you want to put the try blocks in there, right? But that would be next level. You get the logic to work first, and then you can ramp it up for the better user experience. There you go. I know this is a pretty simple little example. I know one thing we forgot to do though. Right, and so I'm like recording this in, right? But we should have closed our in file. Like after you process, you should close the file. And I could argue actually once you read it in, you can close the file. You could do it right here actually. But it's just considered good etiquette. All right, moving on to the next exercise. We have one left. We should have enough time to finish this just barely. I'm going to read the instructions to you guys first, because this is kind of like delving into kind of data science-y kind of stuff, right? and there's this link here. So I'm going to go ahead and click on this. And basically, okay, so it's telling me it doesn't exist. And you guys notice that I'm going to the CIA because apparently they keep data on everything and they do publish a lot of the data, right? Hopefully not your grades, right? Kidding. But at one point in time, this link, if you followed it, would take you to a file, which I happen to have captured, of course, here. And once again, I'm going to drop, oops, I'm going to drop that file in the chat so you guys can grab it. So we should use the same data. And then I'm just going to open this up and show you what the data contains. And so what this is this is a text file, which is a raw data dump from, I don't know, probably their database system or something like that. And the way the data plays out in the file is I have a number. So every country on earth is numbered, right? And then they list the country name, a $sign, a bunch of spaces, commas in the middle of numbers. But basically what this is it shows in 2004, the per capita income of every country on planet Earth. Okay, and surprise, you know, American people, we're not at the top of the list, by the way, right? And really not even close, right? We're not even halfway to the top of that list numerically. And I think this is eye-opening for a lot of people. I think people kind of make this, we're the richest country in the world. It's like, no, not everybody, right? You know, and the countries that are at the top of this list, by the way, are countries that have very, very high standards of living. And that means that basically there's enough people earn enough money so that every man, woman, and child of any age is earning this much money is flowing through the country. Where, you know, and granted, this is, you know, 20 years ago, right? And this has changed. But at that time, that was the per capita income in the US. Still not that bad, right? Because scroll down, right? Go to the bottom of the list, and there's places where, you know, they're not really making anything. So if you complain ever about the money you make and your rent that you pay and how do I get by, you know, you can barely afford a cheeseburger, you know, these people really can't afford anything, right? And so, okay, so there's a little, you know, sociological lesson in there too, right? But this is a data set, and I say this to the data analytics and AI people, that this is a lot of the kind of stuff that we do, right? We get data is presented to us all the time, right? And we can use it. You can use that data to create visualizations or to put it up against other data so that we can make decisions or calculations or create apps or whatever we need to do, right? The data is out there. And what I think is really amazing about it is there's organizations like our government that publishes a lot of that data. Here's some like really crazy data sets that exist. There are websites out there where I can go and I can get the data dump of all the titles that are on Netflix. How about that for a weird data set, right? You know, because you go to Netflix and you look up a thing and it's like, how come I always see the same like 5 things they want me to watch, right? And then you look on that list and you go, I've never seen that on there. I've never seen that on there. Right? It's kind of like that, right? So it's kind of interesting. And one of the websites where you can do that, by the way, and once again, you know, data students, here's one of them, and they have just a whole area on data sets, right? And just for example, you can just type in Netflix. I don't know if it's still out there. Well, okay, there you go. There's a CSV file with all the titles on Netflix, just in case somebody else has taken that data and combined it with the IMDb scores. You know, so you think you're geeky, there's people way geekier than you, I assure you, right? All right, so here we have this data set, but we have some problems with the data set. We've kind of done a little bit of work like this. We're able to read columns of information, but as you notice here, what we're really looking to do here is basically read the column, this column, which has the country name, exclude the $sign and all this space and the comma from the number, and maybe create a key value pair of the country name and the per capita income. So when somebody says, hey, what's the income of Switzerland, it will just respond 44.5. Wouldn't that be handy? Okay, so that's basically what we're doing here, but we're going to use that data file. So make sure it's in the same folder with your code. We're going to create a new file, do a save as on that. And this is going to be exercise 8_17. All right. And we're going to try to do this in kind of hurry up fashion to a point. So here's the top part of your program in the chat. So I'm just going to drop that right in at the top of the file. So first, I'm going to create an empty dictionary. That's what this is, this first line. Then I'm going to prompt. Well, no, actually, I'm not prompting. I'm just brute force reading the file in, right? Just giving the name right there, no prompt. Read only, don't want to change data, just read it. Next, we're going to run a for loop. So the for loop will begin like this. So for each line in the in file, first we're going to split the line based on tab stops. How do I know there's tab stops in this file? By arrowing through it. So if I put my cursor in here and I go to the end of the one and I press the key once, it jumps. So you can see each single key press, but notice I get to some points where it's like it's going space by space, or is it tab by tab? I'm not really sure, but it seems more like a tab than a space. But I know it's tab delimited, so that's why, right? So we're doing a line split, and we're splitting on tabs. And look how we use like the escape sequence for a tab to determine a tab. I think that's really clever. Next thing that we're going to do is we're going to, and I'll give you that code plus this code. So the next thing we're going to do is we're going to remove the $ and the comma from each line. And so there's this command called replace that reads in the string and looks for a character and replaces it with a different character. And so every $, every comma is removed and replaced with nothing. Then we're going to allow it to add each country to the dictionary, converting it all to uppercase. Why? That's what we decided to do. Right. So everything that's typed in as a search will be converted to uppercase. And we're also taking the number and converting it to a floating point number also. Parts 1, country name, parts 2. All right. Are those lists or sets there? Yeah, it's a really good question, right?
List.
Yeah, that is a list, right? It has to be, or a tuple. It's got to be one of those two. Right. All right. All right. Now we're going to read in the queries from the user. So we're going to allow this pretty much processed it all and put it into a data structure called incomes that we're not going to be able to query. So this is kind of weird. And so then we're going to prompt the user and convert it to uppercase right as they type it in. So they're going to type in a country name and then press enter. Then we're going to run a while loop. So as long as they don't type quit, they can keep typing in country names. You guys like this copy paste thing, right? Sure makes coding easy. but really the concepts are important here, right? So this is really what I want you to focus on is more the concepts. So now for every country that they type in, we're going to check to see if that country is in the data structure of incomes. Incomes is a dictionary, right? Parts, this is a list to help process it. But what we're doing with those parts, and this is the part I think most people are missing, is we're taking that list entry and converting it to a key and a value for incomes. So this part sets the key. This side sets the value that travels with it. This is really kind of a weird concept, but we can manipulate both at the same time. That's where it gets really deep, right? And maybe you're not latching onto that right now, but when you finally get that concept, it's like, oh wow, this is kind of like doing like two variables at once. Well, yes, exactly, because the values travel together in pairs, right? All right, so now we'll say if the country's in the income dictionary, then we'll display the value. So how do we find the value? We throw the country name in, it looks it up in the dictionary, and it returns the value, which is the money that came from the other column, this part. Right. But what if it's not? Okay, well, if it's not, then we do this. We say else, that wasn't a recognized country. Check the spelling, right? I dare you to spell Liechtenstein. Go. Look at the spelling bee. Sorry. Right, you can't buy a vowel. Bad joke after bad joke. Only Alex is laughing. Next thing that we're going to do is this. Yeah, don't panic, it's in the chat. We're going to read in the next country. So like we're still in the while loop. So they're either going to type quit or another country name. Another country name, we look it up. If you type quit, we're out of the loop. And that's it. That's all it takes. However, right, and so I often like say this to people, not a bad idea to bid them a polite farewell, right? Put in a blank line before it, let them know the program's done. All right, once again, if we're reading in files, should we use try blocks? Yes. Could I put that in while loops to make sure? Sure. You know, any place that we could have input and output errors, you should probably have try blocks. Could I put loops around the whole thing and keep it running forever? Yes. Could I create main methods and drive everything through functions? Sure. Right. All of that's on the table. We just don't have time to do all of that collectively. Right. But if I was doing a good application, I would do all those things. Right. See, but you have all the, you know, going back to the recipe things, we have all the ingredients, folks. Right. Now it's just a matter of how you combine them together to make a dish. Right. So here comes the run. All right. US. Oh, wait, that's not how it's in there. How about United States? All right. How about, I think Qatar is one of them, right? How about China? Does that surprise you? They make everything. Why is the income so low? Right. Okay, we're 20 years on. Maybe they make a whole lot more now. But yeah, well, here's part of the answer to that, because they take care of it. You know, you don't have to pay for health insurance or medical bills. Yeah, excellent. Right. All right, let's just type quit to get out. But I think that proves that it works. What's fascinating about this is we took a data set. Okay, granted, it's not a huge data set. It's 200-300 entries. But what if it was like 10,000? I could take that data set, do exactly what I just did to it, and then run an application that allows me to basically like search it like a database, like really easily, or use the result of that program to drive a different program, one program that feeds another. Think of the crazy powerful stuff you can build. It's really just an imagination thing that, like, what kind of data sets could I use? What could I have that feed into? Well, that's all in your head. What is that? You tell me. Right? Maybe you have that next great app idea, right? Yeah, crazier things happen, believe it or not. All right, folks. That's the exercises for tonight. We are past time. Is everybody okay? All right, I'm going to stop the recording here. But if you have